Okay, so we're going to look at the angle of angle at the center of a circle. The rule is that this angle over here, we'll call it 2A. Sorry, A for angle. This angle in here is half the size of this angle in here. And what we're going to do is we're just going to look at where this actually comes from. Now, it takes a few steps, but they're pretty straightforward when you look at it. So this is what we're going to show. I'll just get rid of it for now. All right. Building up, what we're first going to do is we're going to join points O and point B using a construction like that. Now, think about it. OA, OB, OC, how do they relate to one another? Yeah, they're common radii. OA equals OB equals OC. And the reasoning for this is radii. Radii of the circle, or just radii. So therefore, we immediately know that these sides are all equal. Now, I want you to think about triangles OAB and OBC. What is interesting about these triangles? What sort of triangles are they? Yeah. Triangle OAB and OBC. Isosceles. And isosceles triangles, what property do they have? There's something really useful about isosceles triangles. Think about the angles. Yeah, the two angles touching the common sides are, actually I won't use that symbol. I'll use this symbol. They're the same. And these guys are the same. And we're going to call these alpha and beta. Just like that. Now, reasoning for this is isosceles triangle. All right. Next thing what we're going to do is we're going to form a statement for this angle here, so ABC, where ABC is just equal to alpha plus beta. Why? Because it's sort of, you can just see it is. All right, now, we're trying to figure out what is this angle in here and how does it relate to this guy. Look at the relationship here. This angle plus this angle plus this angle should give us what? 180. 180? Double it. 360, because it's the angle at a point. Do we know what these angles in here would be? We know we're working with triangles and we know that this is alpha, this is alpha. So what would this guy be?
180 take 2 alpha.
Bingo. It's the internal angle sum of a triangle, so therefore this has to be 180, take away the other two sides. And similarly for this guy as well. So angle AOB has to be 180 degrees, take away 2 lots of alpha. And we know this because it's the internal angle sum of the triangle. Likewise, it will be COB or BOC. Doesn't matter which one we do. 2 beta. And it's the exact same reason. So, because of that, this is 180 take 2 alpha. This is 180 take 2 beta. So, can we figure out what this guy would be? Bingo. We know that angle AOC is going to be 360 degrees. Take away AOB. Take away BOC. This is angle at the point. Hence, subbing everything in, 360. This is going to be 180 degrees, and it turns into a plus 2 alpha because it's take over here. So it's take 180 plus 2 alpha. Take 180 plus 2 beta. These cancel. 2 alpha plus 2 beta. Hence, angle AOC is 2 lots of alpha plus beta, or in other words, angle AOC is 2 angle ABC. Pretty cool stuff, right? Doesn't matter where you drag point B, it's always going to be half the size of whatever that guy is. And we call this angle at the center. Simple.